Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is chapter 9, and it's about matrices and determinants. The first section, 9.1, is about matrix solutions to linear systems. The first objective is to write the augmented matrix for a linear system. So we would like to know what is the meaning of augmented matrix? What is an augmented matrix? Well, an augmented matrix has a vertical bar separating the columns of the matrix into two groups, like this. The coefficients of each variable are placed to the left of the vertical line. So these are the coefficients of the variables. So for example, the coefficients of x are here, 3, 1, 1. The coefficients of y will form the second column. The coefficients of z will form the third column. The coefficients of each variables are placed to the left. The constants are placed to the right. The constants, these numbers, 31, 19, 25. But notice that the system has to be written in this equation. X, Y, Z here, and the number, the constant, is in the right-hand side. And notice that you can write the first, the first line, the first row in the matrix, in the augmented matrix, represents the first equation. So 3, 1, 2, 31. So each row represents an equation, and each column represents a variable, except the last one after the vertical bar, it represents the constant numbers. This is another example. Here there is no, in the second equation, we don't have x, so the coefficient of x is 0 and we write 0. In the last equation, the coefficients of y and x are not here, so we write 0, 0. So we know now how to form the augmented matrix. For example, write the augmented matrix for the system. So what would be the augmented matrix? Let us write the coefficients of x. Let me do it here column by column, okay? So coefficients of x are 0, 1, 2. Coefficients of y are 2, 2, negative 3. You write the negative. Coefficients of z, negative 1, 1, and plus 2. Then I put the vertical bar and write the constants. So this is the augmented matrix for this linear system. Another question, write the augmented matrix. I'll do it here row by row. So let me start by the first equation. So 1 minus 2, coefficient of z is 0, and the constant term is 2. The second equation, 2, 3, 1, and 11. The last equation, coefficient of x is 0, coefficient of y is 1, negative 4, and the constant is negative 7. This is the augmented matrix for the system. Please do the same. Write the augmented matrix here and write the augmented matrix here. Check your information. Here the augmented matrix is given, and we need to write the system of the linear equations represented by this augmented matrix. And he said use x, y, z if you have 3 columns, or w, x, y, z if you have 4 columns, 4 variables. So can I write the first equation? Can you give me, if this is here x, this is y, this is z. So what would be the first equation? Yes, 5x plus 0 times y, no need to write it, plus 3z equals to negative 11. What is the second equation? Coefficient of x is 0, so we don't write it. Coefficient of y is 1, so I just write y minus 4z equals 12. Coefficient of x in the last equation is 7, plus 2y, coefficient of z is 0 equals to 3. So this is the linear system represented by this augmented matrix. How would we solve the system? After we write the augmented matrix, our goal would be to change the augmented matrix to this matrix. Okay, look carefully to this matrix. This is called the main diagonal, the main diagonal of the matrix. We must have 1, 1, 1 on the main diagonal. Below each one, I have zeros. So 1, 0, 0, 1, 0, 1, there is nothing below. All these numbers, A, B, C, D, E, F, I don't mind. It could be any numbers. But the most important thing, these numbers 1, 1, 1, 1, and here 0, 0, 0. This is our goal, is to change the augmented matrix to this matrix. How would we do that? We will use row operations, what we call row operations. So let us in objective 2 try to understand what are the matrix row operations. We use the matrix row operations to change the augmented matrix to the row echelon form. What is the row echelon form? It is this form. This form is called row echelon form. What kind of operations can I do that does not change the solution of the system? We get systems with the same solution set. Otherwise, if you do an operation that changes the solution of the system, that's it. You will not be able to solve the system. So we need operations do not change the solution of the system. 3 operations only are possible. Only 3 operations are possible. The first one, you can interchange any 2 rows. Any 2 rows of the matrix, you can interchange them. What is the meaning of interchanging these 2 rows, for example? Row 1 and row 2. You are writing this equation instead in the position of this equation, changing the positions of equations. Does this change the solution of the system? No. So you can interchange any 2 rows. How do we write this? We say Ri, Rj, and use this arrow, which means I'm going to interchange Ri with Rj. So if you write R1, R2, it means you will put R1 in the position of R2 and R2 in the position of R1. We say interchanging. So this is the first row operation. The second row operation, you can multiply any row by a non-zero number. So this row, for example, I can divide by 5, which means I multiply by 1 over 5. So multiplying by 1 over 5 or dividing by 5, the same. Can we do that? Does this change the solution of the system? No, because it means you are dividing this equation by 5. And when you divide the equation by 5 or multiply by 1 over 5, you do not change the equation. You do not change the solution of the equation. Okay? You do not change the solution of the system. So you can multiply by a non-zero number whenever you like, you need. How to write this? We write it like this, KRI, which means I will multiply Ri by the number K, which is non-zero number. All right. What is the third row operation? The third possible row operation? Well, I can choose a row, multiply the elements of this row by a non-zero number, and then add the products to the corresponding elements in another row. Okay? This operation does not change the solution of the system. And let us understand it. row I, for example, I multiply the elements of row I by k. So I write k ri and I add this plus to row j. So kri plus rj. This is the third operation. And I replace the answer by row j. Let me do this operation on an example so you can understand. Let us check here first. What is this question? Can you clarify what I am supposed to do to find KRI plus RJ? Which row do I work with and which row do I replace? You replace RJ, okay? RJ is replaced. Row J is going to change. The elements in row J will be changed. And you work with Ri. Ri is not changed here. So the second one here is going to be changed. Let me give you an example. Let us solve this example first. Perform this operation. What does this operation says? Interchange row 1 and row 2. So I will write the matrix again, but row 2, I write it first. And row 1, I write it second. Row 3, there is no change. So I performed this row operation. I interchanged row 1 and row 2. 1 over 3 R1. I will work always with this matrix, okay, with the original matrix. 1 over 3 R1. All right. What to do? R1 row 1, I multiply row 1 by 1 over 3. So what would happen? 1 over 3 times 3, 1. Multiplying by 1 over 3 like dividing by 3. So 18 divided by 3 is 6. Negative 12 divided by 3 is negative 4. 21 divided by 3 is 7. If the calculator is allowed, please use the calculator to do these operations, not to do any mistake. The second row and the third row are not changing because there is no row operation to change them here. Now, let us understand this one, the third row operation. Row 2 should be multiplied by 2, and you add that to row 3. All right. So let me write the matrix again. 3, 18, negative 12, and 21. Yeah. And the second row is this one, and the last row is this one. This is the original matrix, and we are going to use this row operation to change this matrix, okay, to a new matrix. Look, please try to understand. Row 1 here is not changing, so I'm not going to write it now, okay? Row 2 is not going to be changed. We will change row 3 here. How we change row 3? By 2 times R2 plus R3. So 2 times 1, which is in R2, plus R3, which is negative 2. We do this for every element in row 3. So 2 times 2, which is this one, okay, minus 3. 2 times negative 3. So I multiply the elements of row 2 by 2 and add them to the corresponding elements in row 3. 5 multiplied by 2 and add to the element in row 3. This is the way to do this operation. You can write now these two rows again. We do not change anything in them. So I hope you understand this operation now. And now you can just write the matrix again and evaluate using the calculator. 2 minus 2 is 0. 4 minus 3 is 1. Negative 6 plus 4 is negative 2. 10 minus 6 is 4. So this operation changed row 3 into this one. All right. So I have again 3 row operations, interchanging, multiplying any row, and KRI plus RG. All right. I leave this for you. I think this is easy. After what we said, we can solve it easily. And also please do this one. Perform this operation, interchange row 1 and row 2, multiply row 1 by 1 over 4, and try to do this one. Multiply row 2 by 3 and add it to row 3. So row 3 would be changed. Let us do this exercise. Let us perform this operation. This operation will change what? Will it change R2? So R1 is not going to be changed. So I am going to write it as it is. And R3 is not changing. Now pay attention. Negative 3 times 1 plus 3. That would give you 0. Negative 3 times negative 3, that's 9, plus 1, that's 10. Negative 3 times 2, that's negative 6, plus negative 1, that's negative 7. Negative 3 times 0, that's 0, plus 7, that's 7. So this is how we do this operation. Please use the calculator if you are allowed to. All right. We know now the matrix row operations. Now the question, what do we need to do again? Well, let me say first, we will solve using Gaussian elimination. We will solve the systems using Gaussian elimination, matrices and Gaussian elimination, or simply Gaussian elimination. We mentioned our goal, if you remember. We need to reach to this matrix, 1, 1, 1, and below zeros. How to reach to this matrix? What to do? Well, pay attention. We write the augmented matrix first, and then, and please understand and follow these steps step by step. Get 1 in the upper left hand corner. So you need to make this number 1. Now, how to make numbers 1? Anyway, I need some numbers, I need to change them to 1. Some numbers, I need to change them to zeros. This is all what we need to do. Changing some numbers to 1, changing some numbers to zeros. How many operations I have? I have 3 operations. Pay attention. These 2 operations, the first 2 operations are used to change numbers to 1. Please do not use them to change to zeros. The last one, number 3, only number 3, only operation number 3 is used to change to zeros. Okay? If you follow this, you will not make any mistake in Gaussian elimination method. So You make this number 1. How? Either by interchanging two rows or by dividing by a number or multiplying by 1 over 2, dividing by 2. Then you use this one, not anyone else, to make these two numbers zeros. How do you change to 0? You use the last operation, KR1 plus R2, KR1 plus R3. You will change these two zeros. So you will finish the first column like this, 1, 0, 0. Now you go to the second column. You get 1 here in the second row. How do you get 1? Either you interchange, and by the way, you always interchange a row with a row beneath it, below it. You don't interchange this one with the one above, even if there is a 1 here. No, interchange this one with the one below. And then use this one to make this number 0. How to change to 0? The third row operation, R2, KR2 plus R3. And then make this number 1. There is no rows below to interchange. So here you just divide by the number here. This is the way. Finish column 1, finish column 2, finish column 3, you reach the row echelon form. After you reach the row echelon form, you write the system and you use back substitution to solve the system. I will leave this for you, okay? And I will solve a system, a complete question for you. So please pay attention. Use matrices to solve the system, or use Gaussian elimination method to solve the system. The first step is to write the augmented matrix 3, 1, 1, 1, 1, 3, and 2, 2, 2, and vertical bar, and 31, 19, 25. So this is the augmented matrix. Let us change it to row echelon form. First, this number must be 1. How to make 1? If you have 1 below, interchange. If you don't have 1 below, divide by 3. That's it. I have 1 below. So I'm going to interchange row 1 and row 2. I can interchange row 1 and row 3. Do that, please. No problem. You will reach to the same answer at the end. Interchange row 1 and row 2. So 1, 1, 2, 19, and 3, 1, 2, 31, 1, 3, 2, 25, and the vertical bar is there. Good. Now this number is 1. That's excellent. This number is 1. I did the first step. Do you remember the second step? These two numbers must be zeros. Okay. How to make them zeros? I use this one. I use this number to make these two numbers zeros. How can I use this number? I use what? The row operation number 3. I multiply row 1 by a number and add it to this. Well, if this is 3, if I multiply row 1 by negative 3, the negative of 3, which is negative 3, and add it to row 2, then negative 3 plus 1 would be negative 3 plus 3. I'll make it 0. Did you get it? So 1, you have 1 here. What to do? You multiply row 1 by negative of this number, by negative 1. So if I multiply row 1 by negative 1 and add to row 3, then I change row 3, then this number would be also 0. So let us do it. The first row, no change at all. Now the second row, and pay attention. Negative 3 times R1 plus R2. Negative 3 times 1 negative 3 plus 3, 0. Negative 3 times 1, negative 3 plus 1, negative 2. Negative 3 times 2, negative 6 plus 2, negative 4. All the numbers of row 2 will be changed. Now, negative 3 times 19 is negative 57 plus 31, negative 26. So this number is negative 26. So I got 0 here. That's excellent. Now I do at the same time, now also I do the second row operation. This one, negative R1 plus R3. Go ahead. Negative, multiply negative by R1, add with row 3. Negative 1 plus 1, 0. Negative 1 plus 3, 2. Negative 2 plus 2, 0. Negative 19 plus 25. That's just 6. So now I finished from column 1. 1, 0, 0. That's excellent. That's what I want. What is the second step? What should you do now? Well, I should go to column 2 and I need this number to be 1. How to make it 1? Well, I can interchange it with the row below, not the row above. Because if you change it with the row above, the 0 will be changed and you will lose what you did in the first column. So please listen carefully and do as I tell you. So now I don't have 2 here, but I'll do something. I'll divide row 3 by 2. Or instead of dividing, I'll say 1 over 2 times row 3. Why? I'm making 1 here. So 1, 1, 2, 19, 0, negative 2, negative 4. Well, I don't see a need of this, but it's okay. I don't see a need of this. I can make negative 2 1 easily by dividing by negative 2, or just 1 over negative 2 times R2. I will do this step if when I divide row 2 by negative 2, I get fractions, because I don't want to deal with fractions. But now, negative 2 over negative 2 would be what? Would be 1. And negative 4 over negative 2 would be 2. Negative 26 over negative 2 is just 13, and there are no fractions. So everything is nice. And let this be 2. Keep it, leave it as it is. So now I finished from this one. Now what is next? This number, I must make it 0. How to make it 0? I use what? I use this one, not anyone else in the column. This one has to be used to make the 2 0. Good. How? Well, look here. What is this? This is 2. So what to do? Negative 2 R2 plus R3. And do you notice that I write this operation here beside row 3? Why I write it beside row 3? Because I'm going to change row 3. So I tell him that I'm writing it here because I'm going to change row 3. Good. So row 1 as it is. Row 2 as it is. No change in it. Now let us change row 3. Well, if you have 0 in row 2, then nothing will happen below. Why? Because negative 2 times 0 would be 0, plus 0 would be 0. So if this row that you are working with, row 2, whenever you have 0, just write whatever below it, because there will be no change in it. But let us now multiply negative 2 times 1, negative 2 plus 2, that's 0. Negative 2 times 2, negative 4 plus 0, negative 4. Negative 2 times 13, negative 26. Plus 6, that's negative 20. Excellent. I finished column 1 and column 2. Now the next step is this number. I just need to make it 1. And after making it 1, I will reach the row echelon form. So how to make it 1? No interchange, finished. Just divide by negative 4 or multiply by 1 over negative 4. So then the matrix, the last matrix in the row echelon form would be 1, 1, 2, 19, no change in row 1, 0, 1, 2, 13, no change in row 2, and here I will divide by negative 4. Negative 4 over negative 4 is 1, negative 20 over negative 4 is 5, and now the matrix is in the row echelon form. Now how to continue? Write the system. The first equation would be x plus y plus 2z equals 19. The second equation would be y, because the coefficient of x is 0, plus 2z equals to 13. And xy zeros, so z is equal to 5. So I have the value of z from the last equation. I use back substitution. What is back substitution? I go back to equation 2. I replace z with 5. So y plus 2 times 5 is 10 equals 13. So y is 13 minus 10, which is 3. And now I go back to the first equation. I replace z by 5 and y by 3. So x plus, what is y? 3. What is z? 5. 2 times 5 is 10 equals 19. 3 plus 10, 13. 19 minus 13 is 6. So what is the solution set of the system? X is 6, y is 3, z is 5. So that's the solution as a point, okay? This is the answer of this question. You can check your answer by substituting here x6, y5, y3. What did I write? Yeah, z is 5. So 6, 3, and 5. For example, 6 plus 3, 9, plus 10, 19. You will find that these three values for x, y, z satisfy all the three equations, and that's why they are the solution of the system. I will leave this for you. Please do it by yourself, following the same steps. Here, solve each system of equations using matrices. Use Gaussian elimination with back substitution or Gauss and Jordan elimination. Well, I will solve this question for you, and this would be the last question. And I will solve it using Gauss and Jordan elimination. And let me tell you what is the difference between Gauss and Jordan elimination and Gauss elimination with back substitution. Well, in Gauss elimination with back substitution, we start by this, making this one, and then making these zeros, and then making this one, and then this zero, and then this one. And we finish. We stop here. This is the Gaussian elimination method. Well, pay attention. Gauss and Jordan is a little bit different. This is the same. We make this one and these zeros, and this also one. But after making this one, in Gauss and Jordan, we use this one to make this number 0 and this number also 0. So above and below, not only below. And after we finish the second column, we go to the third column, make this number 1, and then use it to make these two numbers zeros. So in fact, Gauss and Jordan, you change the matrix into the identity matrix like this, or we call it echelon form. Okay, uh, maybe there is another name for it. For you just for now, it is the identity matrix. And here, of course, there will be some numbers, and the answer would be immediately given. X would be equal to this, Y would be equal to this, and Z would be equal to this. So you do more steps in Gauss and Jordan by making these numbers zeros, but immediately you get the answer and there will be no back substitution in this case. So let me use Gauss and Jordan to solve this system. As usual, first write the augmented matrix. All right, this number must be 1. Alhamdulillah, it is 1. That's excellent. Use this one to make these numbers now zeros. All right. How? Anybody knows the transformation? This is 2. So negative 2 R1 plus R2. And I write it here. This is negative 1. So 1 times R1 plus R3. All right. Which row is not going to be changed? Row 1. We will work with row 1, but not changing it. Let us change row 2 now using this transformation. Negative 2 plus 2, 0. Negative 2 plus minus 1, negative 3. Negative 2 times negative 1, 2 plus 1, 3. Negative 2 times negative 2, 4 plus 5, 9. So we changed row 2. Let us change row 3. R1 plus R3. 1 plus minus 1, 0. 1 plus 2, 3. Negative 1 plus 2, 1. Negative 2 plus 1, negative 1. Excellent. I finished working with the first column. Let us go now to the second column. Let me divide row 2 by negative 3. Row 2. Okay. To make this number 1, because I need to make this number 1. So 1, 1, negative 1, negative 2, 0. Negative 3 divided by negative 3 is 1. 3 divided by negative 3 is negative 1. 9 divided by negative 3 is negative 3. The third row as it is. Now what to do? Gauss Jordan. This one, I will use it to make these two numbers zeros. How can I do that? This is a 3. So negative 3 times R2 plus R3. This is 1. So negative 1 times R2 plus R1. So I'm going to change R1. R2 is not changing here. So let me write it. Let us change R1. Notice that 0 in R2 we have 0. So this one will not change and this one will not change. Because negative 0 is 0, plus 1 is 1. Negative 3 times 0 is 0, plus 0 is 0. All right. Let us change R1. Negative 1 plus 1, that's 0. Negative 1 times negative 1, 1. 1 minus 1 is 0. Negative 3, 3 minus 2, 1. Let us change the last row. Negative 3 times R2. Negative 3 plus 3, that's 0. Negative 3 times negative 1, 3 plus 1, 4. Negative 3 times negative 3, 9 minus 1, that's 8. I finished working with column 2. Now let us go to column 3. What do I need? This number has to be 1. So 1 over 4 R3 will make it 1. Eight over 4 is 2. Now what to do? I use this one. I should use it to make this number 0 and this number 0. Alhamdulillah, it is 0. Okay. How to make the negative 1 0? I multiply row 3 by 1. So R3 plus R2. I add it to R2. The first row is not changing. And the third row. The second will be changed. Notice I am using row 3 here because I have 0, 0, so there is nothing changing here. If you want, you can add 0 plus 1, 1, 0 plus 0, 0. 1 plus minus 1, 0. 2 plus negative 3, negative 1. And I finished. This is the Gauss and Jordan elimination. And you can read immediately that x is 1, y is negative 1, z is 2. Because here 1, the coefficient of z is 1, so z is 2. And the solution set consists of the point 1, negative 1, and 2. I hope you can try this exercise by yourself, please, using Gauss and Jordan to learn Gauss and Jordan. That's the end of this lecture. Thank you very much, and I wish you understood section 9.1 by now.